So, a warm welcome to today's webinar, Smart Shading with KNX Weather Station. I'm glad that you all found the time to attend our webinar today. Today's webinar is gonna take place live. So, if you have any questions over the course of the presentation, please do not hesitate and use the chat functionality or the question functionality on the top right in the GoToWebinar application. My name is Bastian Elsner, and I'm happy to guide you through today's webinar. As a starter, what comes to your mind if you see a facade like this? Feel free to give some feedback in the comments. So the biggest difference you can see in those pictures, they use different functionality in order to cool down the building and also to reduce the heat input. In my opinion, one clearly looks more appealing than the other. But you also need to admit that it's quite difficult to set up an automatic shading system. How you can do that with KNX, we will discuss today. So after this webinar, you will be able to select the right weather station for your project. You will know how to install the SunTracer Pro weather station correctly, and you will be able to independently implement automated shading with the SunTracer Pro KNX. We have separated today's webinar in different modules. In the first module, we will start with a general comparison and the correct installation of a weather station. Next up, we'll discuss the comparison and the overview, plus the mounting. In the second module, we will focus on the SunTracer KNX Pro. Since this is our biggest weather station with the most product capabilities, this is best to discuss with this one. First, we will have a look at the special features of the SunTracer KNX Pro. Next up, we will discuss the different thresholds that you can use for wind direction and the wind alarm. Next up, we will set up a facade automation. So after the first module, you will be able to select the appropriate weather station and to distinguish a good from a bad installation. Let's start with the overview. So on the left photo, we can see the largest version of our KNX weather stations, the SunTracer KNX Pro, which is also the star of today's webinar. This has a facade automation for up to 12 facades. The special feature on the weather station is that it can detect the wind direction. This is the only model that we have that can do this. On the second photo, you can see the SunTracer SL series. We offer these in the version SunTracer SL, SunTracer SL Lite, and SunTracer SL Basic. We will take a closer look at the differences between the models on the next page. In the middle, you can see the P04 KNX weather station. This is the smallest version of the KNX weather stations. The device has no facade automation or logic functions included. With this device, only the measured values can be sent on the bus, for example, to a building management system. On the right side, you can see our newest weather station. It's a Wind Dancer KNX GPS. The device has the same functionality as the SunTracer SL Lite, but the novelty is that the wind measurement of the device is done by a wind wheel and not electronically. For a quicker and better comparison, you can have a look at this chart. This can help you very well to choose the weather station that you actually need for your project. So the following table shows the weather stations in a comparative overview. The table is very helpful in choosing the right weather station. So in the table, you can see under the point automation how many facades the weather station can control. In the first four rows, you can see the sensor system, such as air pressure, air humidity, wind direction. The table can be found on our website. Next up, funnily, this is one of the topics where most integrators makes the grave mistakes. It's actually the installation and assembly of the weather station. So before we get into the next section, I would like to give you the opportunity to ask some questions. So I will make a super quick break, just a couple seconds, to give you time to ask those questions. All right, no additional questions. I think we can hop into the next section. So all weather stations with the housing shape of the sun tracer SL, as seen on the photo on the right, are mounted identically. The weather station can be attached directly to a pole or on the roof with a clamp. Likewise, the weather station can be mounted on a facade wall. Here it must be noted that depending on the wind direction, the weather station is located in the lee of the facade. Therefore, the installation on the facade only makes sense if shading sits on the same facade. Furthermore, the weather station can be mounted with the help of a boom and set off from the facade. The front of the weather station with the wind sensor must be oriented towards the south. In addition, a free space of at least 60 centimeters must be maintained below the weather station. The weather station cable should be routed in an arc to allow the water to drip off, as you can see on the picture. There has been one question, 1 second please. So, very interesting. Actually, one of my favorite questions just popped up. The question is the following. What is better, electronic or mechanical wind detection? So, in my opinion, the electronical wind measurement will always have some advantages over the mechanical wind measurement. This is the reason for this is, as you can see here on this picture, if the wind blows from below, so the uprising winds we can detect with the electronical wind measurement. This is very important for higher buildings. I would say if you have more than 4 floors, this is already a very important measurement just to assure the safety of the shading. And um, another point is that the electronic wind measurement is more expensive than the mechanical wind measurement. So this is a big difference because the electronic wind measurement needs to be calibrated in a wind chamber. This you do not need to do with the mechanical wind measurement. Also, the components for the electronical wind measurement is more expensive than it is for the mechanical wind measurement. So if you have a building that is not too high and you don't need to detect the uprising winds, then mechanical wind measurement is fine. If you have a higher building, then I would always recommend electronic wind measurement. So if you have a smaller project, single family home, small villa project, mechanical wind measurement is totally fine. If you need to go higher up on the building, electronical wind measurement is the way to go. I hope I could answer your question there. Let's move on to the next model, which is the mounting of the SunTracer KNX Pro. The SunTracer KNX Pro weather station must be mounted on a mast on the building due to wind direction measurement, so as high up as possible. A mast extension as well as suitable mounting material is included in the scope of delivery. In the next photo, the total assembly with the mast extension is shown. The weather station must be oriented so that the base of the device faces north and the ring faces south, as you can see here. All right, now we already get to our first practical exercise. I kindly ask you to have a look at those 3 pictures, and we will start a little survey in a second where you can just log in your preferred answer. And yes, the question is, which weather station is mounted correctly? We will start the survey now. All right, I'm seeing there are still answers coming in. We wait a couple more seconds and then we continue. All right. Thanks everyone for locking in the answer. It actually has been between answer number 1 and number 3. The correct answer is picture number 3. Picture number 3 is mounted correctly because we have the 60 centimeters below the wind sensor. You can see that on picture 2, 60 centimeters is not given. Also, the weather station is covered by the roof. So how can it detect the rain? So therefore, you see 60 centimeters also is freely hanging, so rain can get on the weather station. This is correct, and this can be seen in picture number 3. All right. Let's do a quick summary of the first module, what we discussed. So we are at the end of our first module, and now we can distinguish different weather station, and we know how to mount each weather station correctly. Do you have any questions at this point? If so, feel free to post them in the chat. We'll make another 10-second break, and then we continue. Oh, and also one thing I forgot to mention. We will record today's webinar and we also send out the presentation as a PDF and also the link to the recording to all attendants after the webinar. We will also send out a quick feedback form where you can give us feedback for the webinar. I would highly appreciate if you could give us your brutal and honest feedback because we are trying to become better from webinar to webinar, and we can only do this if we get your respective feedbacks. All right, let's move on to the second topic, the special features of the Suntracer KNX Pro. So the features of the Suntracer KNX Pro we have visualized in this small graphic. We have, first of all, we have the temperature measurement. We have the wind speed and wind direction measured with ultrasonic measurement. We have brightness sensors, 5 sensors in total. We have the precipitation, we have the humidity, the air pressure, GPS location, GPS reception for location and time, of course. Also, we have the calculation of the sun position. We can set up the automation function for up to 12 facades. We can display the sense temperature, wind measurement where free with ultrasound. We can have the output of wind direction in degrees or in text form. Also, we have the output of air pressure in hectopascal or in text form. The KNX programming can be done via an magnetic switch. So in this chapter, we have learned more about the special features and sensor technology of the Suntracer KNX Pro. Next up, we will discuss the wind threshold values. If you have questions at this point, feel free to post them in the chat. So setting the wind direction threshold values is not integrated in the facade and must therefore be parameterized separately. The wind direction is to be integrated into the facade automation. This is done via an input object, safety. Here, the wind direction threshold value is applied and the output object 1 bit is linked to the input object safety. Okay, so now we would like to have a look at the settings of the wind direction limit. First of all, we have the parameter settings. Here you can set the weather. The values received via a communication object are to be retained after voltage recovery, plus the programming or lost. The range specifications, as you can see in the green box, can be specified via the parameters or via a communication object. The next setting, you can set up a hysteresis. This must be set. The hysteresis is a switching point between range exceeded and no longer exceeded. What the hysteresis exactly is, we will discuss on the following slides. I also have a graphic that will make it a little bit easier to understand. In the next setting area, we can set the delay time from 0 to 1 and from 1 to 0. Here we recommend always to set a delay and from 1 to 0, a 2 second, and from 1 to 0, a 5 minute. This causes that the wind direction must be fulfilled for 2 seconds so that a 1 is sent on the bus. If the wind direction is no longer fulfilled for 5 minutes, a 0 is sent to the bus again. For example, to release the shading after a triggered wind alarm. In addition, there is the setting how the switching output should be sent. For example, on change or on change and cyclically, and adjustable transmission cycle. The output of the threshold value can be deactivated or blocked by an object if desired. Now, next up, the wind threshold values. The setting of the wind force depends on the curtain used and the design or positioning on the object. The maximum wind value must therefore be requested from the shading manufacturer. We have already discussed the first point. For example, the threshold values received via the communication object should be retained, in this case of the wind direction threshold value. The wind threshold value can be specified via the parameters, for example, the fixed values in the application, or via a communication object, for example, via a visualization. In the next step, a hysteresis must be set. The hysteresis can be set in percent or as an absolute value. The hysteresis is the switching threshold between wind value exceeded and undershot. Another example. In our example, we have set 4 meter as wind threshold value. If the wind value of 4 meters per second is exceeded, the alarm 1 is sent to the bus. If the wind value falls below 4 meters per second to 2 meters per second hysteresis, the alarm is deactivated and a 0 is sent to the bus. In the setting of the switching output, we can set how the switching output should work when the threshold value is exceeded. This means that we can select, for example, whether a 1 or a 0 is sent when the limit is exceeded. In addition, a switching delay can be set. A switch on delay 0 to 1 is recommended, so that, for example, small wind gusts are faded out, and the switch off delay 1 to 0, so that only with longer calm is extended again. More about this later though. In addition, we can define how the switching output is to be sent, for example cyclically or on change or both, as well as the cycle time. In the first step, we can specify whether to enable the lock with the value 1 or 0. In the second step, the value of the lock is defined before a communication object is sent. For example, whether the lock is active or inactive after reprogramming. And in the last setting, we can specify if we want to send a certain value when locking, for example, lock active, wind alarm. We already we already talked about the hysteresis. So now we have dealt with the detailed setting of the wind alarm. Now I would like to show you again briefly in a diagram. The blue line shows the actual wind, so the respective wind speed. The yellow line is showing our set wind threshold value, and the yellow dashed line is our hysteresis. So I think this shows graphically quite well how the hysteresis is actually working. The setting of the wind threshold values in the facade control system. So in my example, I used the wind alarm by threshold value. Since I used the wind value measured by the weather station, I have selected the measured value from the internal sensor. If there are individual wind sensors on the building, for example for the objects and the facades, these can be integrated via a communication object. For this, the setting measured value from internal sensors would be set to null. For this measurement value of facade 1, wind is activated. The following object then receives the measurement wind value from the external individual sensor of the facade. A maximum of 12 individual sensors can be integrated. In the right window, we can still see the setting of the wind threshold value. In previous chapters, we dealt with the wind direction threshold values and the wind threshold values, also the wind alarms. Do you have any questions about the sections before we move on to the next topic? I wait a couple seconds and then we continue. Okay, I don't see any upcoming questions, so let's move on to the next topic, the facade automation. I would like now to briefly introduce the individual functions of the facade control system. First off, we start with the timers. So we have the time open and time close. Next up, we have the night closing. Moreover, we have the heat protection. Next up, we can integrate a pyranometer into the facade automation. Next up, we have the rain automatic, indoor temperature block, automatic sun protection, and outdoor temperature block. Later, we will deal with a separate section with the protection functions of the facade. Those are the wind speed, frost, and rain. I recommend remembering those. There might be another quiz later. So before you know which weather station you can choose, you first need to classify how many facades you need to control. For the shading automation, you must always firstly define the individual facades of the building. I would like to show you the classification of the facades by means of some examples which can be used for most building types. So for the first photo, most buildings have 4 facades. The solar protection of each facade should be controlled separately. In the second picture, even buildings with a U-shaped floor plan only have 4 facades either, and they need to be controlled differently. as several are oriented in the same way. For buildings with an asymmetrical floor plan, the division of the facades is somewhat different. The facade with non-rectangular orientation, so facade 3, 2, and 5, and the setback facade 6 must be controlled separately. This division can be seen in the floor plan. Curved round fronts should be divided into several facade segments to be controlled separately. All right, let's do another super quick quiz. How many facades does this building have? We will start the survey now. All right, thanks everyone for voting, and I'm very happy that half of you got the right answer. So the right answer is that the building has 4 facades. All right, next up, we can talk about the alignment of the facade. For facade automation, we need to define the alignment of the facade. The facade alignment corresponds to the angle between the north-south axis and the perpendicular to the facade. North thus stands for 0 degrees. The angle alpha is measured here in a clockwise direction. In the example, the angle here are marked in red and is rotated by 30 degrees to the north. Thus, the alignment for the facades corresponds to 1 equaling 30 degrees. The other angles result from the angle alpha plus 90. You can see this in the figure. The facade alignment results are as follows. The facade 1 with the following angles. Another special use case is that you can have an inclination of the facade. In the picture, you can see exactly that. If a facade surface is not aligned vertically, this must be taken into account for automatic shading as well. An inclination of the facade to the front is counted as a positive angle. An inclination to the rear, as in the figure, is considered a negative angle. If there is no inclination, the value is 0. 0 is entered. In this extract of the ETS, you can see where the inclination of the facade adjustment can be made. Next up, we need to discuss the sun direction. The position of the sun indicates the area the sunlight on the facade, depending on the surrounding conditions. The area must be adjusted. So the sun range often is already restricted by neighboring buildings or plantings, as you can see perfectly in this example. As it can be seen in the following example, the building is already shaded by the trees. You can see the green dots, they stand for the trees. Due to the rising sun in the east, thus natural shading exists and the blinds do not yet need to be lowered. Only when the sun moves during the course of the day, this is the second figure, does it hit the building unhindered. So this is where the shading of the blinds is required. Therefore, this sun area entered in the following parameter settings azimut. For this setting, we offered fixed areas, for example, south, east, west, and combinations. An individual adjustment of the ranges is also possible. For this, the angle range is activated. Now, the individual sun ranges can be entered in degrees. Next up, we can discuss the counterpart, which is the sun height and the elevation. In our example photo, the facade is shaded by the projection roof when the sun is high. Only when the sun is low, approx below 53 degrees, shading is necessary. Of course, we only want to shade when it's absolutely necessary. The values entered in the green box correspond to the sun elevation in the parameter setting. So could be, for example, as in the photo, from 0 to 53. Next up, the brightness. In the following image, the parameters of the brightness sensor are shown. We can select whether we use the internal sensor or an external sensor system of another transmitter for the threshold value. Then we can set the threshold value for the brightness, for example, to 60 kilolux. For falling below the threshold value, a hysteresis in percent or in kilolux can be selected. In addition, there are corresponding delay times for brightness control. For example, an extension delay, short retraction delay, and retraction delay. Let me give you an example. So if the brightness limit value is 60 kilolux is exceeded for 1 minute, the shading extends. If there's a short cloud after the extension covering the sun and a short delay of 60 kilolux interrupted for 10 seconds, the slats can be opened to get daylight in the room again. If this threshold value is not undershot for 30 minutes, the shading is retracted again. Once again, to only shade when it's absolutely needed. In a facade automation, you must also select which shading function is desired. There are the following options. Without tracking. There are the options without the tracking. So the shading goes down in the sun and open the slats to a fixed value. Slats can be set in 4 predefined values. The slat tracking. The slats move automatically with the height of the sun. Shadow edge tracking. The shadow changes the driving position independently and adjusts it to the shadow edge. Shadow edge tracking and slat tracking. The slats automatically track the height of the sun. The shading changes the driving position independently and adjusts it to the shadow edge. The sunshade is only partially closed and automatically lowered only so far that the sun cannot shine further into the room than specified above by the maximum permitted penetration depth. In the next picture, the sunshade for a medium position for the sun. So the sunshade is automatically lowered only so far that the sun does not exceed the maximum permitted penetration depth into the room. In the last picture, the sunshade is automatically lowered almost completely so that the sun does not shine too far into the room. Let's have a look at the details for the slat settings. So first of all, we need to determine what kind of slat types we are having. Both horizontal and vertical blinds can be used for shading the facades. Both types of shading can be controlled so no direct sunlight shines into the room. In order for the shades to be controlled correctly, the distance and depth of the slats must be known. For this purpose, the width and the distance between the slats are measured. These values must be entered correctly in the parameter settings, as you can see here. The possible angle at slat position 0% depends on the mechanics of the shutter and the actuator. Shades that do not fold inward are shown in the 2 pictures on the left. In the first picture, we see an angle of 90 degrees with a slat position of 0 degrees. If the second picture, we see an angle of 10% with a slat position of 100%. Next up, we have shades that fold inwards and can be seen in the picture above, right. Here's the angle, for example, 160 degrees and 100% slat position. The angles must be measured out, for example, with a set square or requested from the shading manufacturer. The determined values are then entered in the parameters. You can see the parameters below. Let's have a look at the slat position for the vertical slats. So the possible angle at slat position 0 depends on the mechanics on the shutter and the actuator. Once again, shades that do not fold inward are shown in the 2 pictures on the left. Shades that fold inwards can be seen in the picture above right, with the angle 10 and the position of 100%. So once again, this must be measured with a set square or requested from the shading manufacturer. And here we can see where you can do the settings in the ETS, the slat angle in percent and the slat movement command. Let's discuss the facade protection. Earlier we discussed the wind alarm settings, remember? So the facade automation offers further protective functions. First of all, we have the frost alarm. So if the outdoor temperature falls below 2 degrees during or up to 5 hours after precipitation, the frost alarm is activated and the shading is retracted. We also have we also have the rain alarm. So in addition, a rain alarm can be activated for fabric shades. This moves the drive to the safe position in the event of a rain. Also, we have the rain automatic. So the rain automatic function causes the blind to extend when it rains, so they are washed and cleaned by the rain. Pretty neat little feature if you ask me. The sun tracer includes a status output for the facades via communication objects. Via the status output X, the status message of all facades can be viewed. With plus and minus, you can scroll down through the individual facades to query the status objects. The same objects exist as individual status messages for each facades. These are called facade 1, channel status output. We can go on with those for each individual facade. All right, let's do another practical exercise. What alarms for the facade automation did we just discuss? We will start the survey now. All right, thanks everyone for posting your answers. More than half of you again got the right solution, so solution C is correct. We have the rain, frost, and wind alarms. All right, so in the past chapter, we dealt with the settings of the sunshade automation. For this purpose, we dealt with the definition and the alignment of the facades. Then we got to know the shadow edges, slat tracking, as well as the slat distances and angles. At the end of the chapter, we got to know the alarm functions and the status output of the automatic facade control. We are already at the end of the webinar, and as indicated earlier, you will receive a feedback form from our end sent to your mail with which you have registered for today's webinar. We review every individual feedback that we receive and try to implement your wishes and feedbacks for upcoming webinars. So at this point, thank you very, very much for attending today's webinar. I'm more than happy to listen to your wishes, suggestions, and future area of interest for future webinars that you would like to have from Elsner Elektronik. I will stay in the call for a couple meetings more in case you have some additional questions. You can also see our service email address down here. So if you have more detailed questions that we can't really cover in today's webinar, feel free to shoot a message at service@elsner-elektronik.de. We are happy to help you. Once again, thanks for attending and have a wonderful remaining week.